last section of the chapter, variation of parameters, but now with matrices. So remember, matrices are a system of equations. Yeah? So given a real n by n matrix A and the homogeneous vector differential equation, x prime is equal to a times x, the general homogeneous solution is this linear combination of all of these u1s through un's, where ci's, each of these ci's are real numbers, for the corresponding non-homogeneous vector differential equation. So once we add this plus b, it's no longer homogeneous. Remember, homogeneous means x prime minus ax equals 0, right? Where now, if you subtract the ax, you would have equals b. So they're no longer homogeneous or non-homogeneous. We're going to let xp in particular be this combination of c1 times u1 and c2 plus times u2 all the way through there, where the ci's here are real functions of t. And then your particular is going to be u times c, given that c prime is u inverse times b, and u is made up of all, it's a matrix made up of each column is going to be each of these u1s, u2s, or un's, and it's a fundamental matrix. All right, so let's do some examples. We're going to find the eigenvalues and eigenvectors of this given matrix A, and we'll find the general non-homogeneous solution to if it's x prime equals ax plus b for this given b value. All right, so here's the first example where you're going to start off the same. You're going to start off by finding the homogeneous solution, right? And to find the homogeneous solution, we did lambda I minus a, which would be lambda minus 0, 0 minus negative 1, 0 minus 2, and then lambda minus 3. So that my polynomial, characteristic polynomial, will be the determinant of this guy. So it'll be a lambda squared minus 3 lambda, and then minus a negative 2. So a plus 2, which means that this guy would factor as a lambda minus 2 and a lambda minus 1. So our two eigenvalues are negative 2 and, or I'm sorry, positive 2 and positive 1. So for the first eigenvalue, let's say it's 1, plugging that in here would give me a 1, 1, negative 2, negative 2. We're solving when is this equal to 0. And obviously I could multiply 2 times row 1, add it to row 2, and that'll zero out row 2. You can do the row operations if you want. I'm just being lazy. x1 plus x2 equals 0 is what this first row tells me, which means x2 is equal to negative x1. And so your first eigenvector corresponding to an eigenvalue of 1 would be a, I'm going to factor it out right away. If I let x1 equal a, then x2 would be negative a. So that means my first solution is e to the 1 times t times its eigenvector. All right, so there's one solution. For the second one, second eigenvalue is 2. Plugging that in will give me a 2, 1, negative 2, negative 1. And obviously multiplying row 1 by negative 1 and then, or no, just row 1 plus row 2, it'll zero out that second row. And so you would be left with a 2x1 plus x2 equals 0, which means x2 is going to equal negative 2x1. All right, so then that means that your second eigenvector would be, if you let x1 be a, then x2 would be negative 2a. And so your second solution is e to the 2t times 1, negative 2. All right, so your homogeneous solution is going to be a linear combination of some constant times the first guy. So e to the t times 1, negative 1, plus some other constant times e to the 2t, 1, negative 2. All right, so Now, what this variation of parameters says is I'm going to let this matrix U, capital U, be the matrix composed of my U1 and U2. And so this guy is my U1 and this guy is my U2. And so e to the t times 1, e to the t times negative 1, e to the 2t times 1, and e to the 2t times negative 2. So that's my capital U matrix. What we want is the inverse of this guy. And if you remember that if a matrix is a 2 by 2 with A, B, C, D, well then A inverse will be 1 over the determinant of the matrix. You would flip-flop the diagonal values. The opposite diagonal will stay the same values, B and C, but they'll both be opposite in sign, like that. That's the quick way to do a 2 by 2 inverse. All right, so what does that mean for us? That means that U inverse is going to be 1 over the determinant of this guy, which would be e to the t times negative 2 e to the 2t. E to the t times e to the 2t is e to the 3t. And then you're going to subtract from it the opposite diagonal, which is a negative, so it'll become a positive. E to the t times e to the 2t is a e to the 3t. So this determinant ends up being, this guy ends up just being a negative e to the 3t. And we're going to multiply that times, taking this matrix, we're going to flip the original diagonal, those two guys flip spots. And this would be e to the t. These two guys stay in the same spot but opposite in sign. So it's a negative e to the 2t and a positive e to the t. All right, so multiplying these guys together, all I'm doing is distributing negative 1 over e to the 3t. And so that makes this a positive 2. E to the 2t divided by e to the 3t will leave me with an e to the negative t. Multiplying negative 1 over e to the 3t times negative e to the 2t will leave me with a positive e to the negative t. Negative 1 over e to the 3t times e to the t will leave me with a negative e to the negative 2t. And then multiplying this times e to the t will leave me with a negative e to the negative 2t. So that's my U inverse. And then what they gave us was C prime. The derivative of C is U inverse times B. And so U inverse is what we just found there. So that's a 2e to the negative t, e to the negative t, negative e to the negative 2t, and e to the negative e to the negative 2t, U inverse. And then B they gave us, and that was 0 times and 2t e to the t. All right, so we're going to multiply these. So 2 by 2 times a 2 by 1. Your answer is going to be a 2 by 1. And you would go row 1 times column 1. So 2e to the negative t times 0 plus e to the negative t times 2t. So you just end up with a 2t. Because the e to the negative t times e to the t just ends up being e to the 0. Do row 2 times this column. It would be this guy times 0, but then plus these two guys multiplied together, which will give you a negative 2t e to the negative 2t plus 1t is a negative t. All right, so that's C prime. It's the derivative. So to find C, you've got to integrate this matrix, which just means you're going to integrate. I'm just going to do it all in one little thing, but you're going to just integrate the top line with respect to t, integrate the bottom line with respect to t. All right, so what does that give us? The integral of 2t would be t squared. And then bottom guy, that's got to be integration by parts, right? You got things being multiplied. But you can do tabular. If you do tabular, you would have negative 2t, a negative 2, and a 0, and e to the negative t. Remember, on this column, you go antiderivative, so a negative e to the negative t, and then a positive e to the negative t, and you add that diagonal and you subtract that one. So you end up with the integral of negative 2t to the negative t would be a, what is that, positive 2t e to the negative t, and then minus a negative, so a plus 2e to the negative t. All right, so that's C. Almost, we're getting there. Now, UP, this particular guy, is going to be matrix U times the C we just found. So matrix U we found was e to the t, negative e to the t, e to the 2t, negative 2e to the 2t. We're going to multiply that matrix times matrix C that we just found, which is t squared and then 2t e to the negative t plus 2e to the negative t. This is a 2 by 2. This is a 2 by 1. Yeah? All right, so multiplying row 1 times this column will give you multiplying these two guys plus multiplying these two guys. Right? Row 1, so ignore this row right now. Multiply this row times this column, element by element. So it's a t squared times e to the t plus multiplying this guy times this whole row. So it's a 2t e to the t plus 2e to the t. That's row 1 of my new 2 by 1 matrix. Now I'm going to, for the second row, I'm going to multiply row 2 times this column, element by element. So a negative t squared e to the t plus this guy times this whole thing. So a negative 4t e to the t minus 4e to the t. Yeah? And then, so that's UP, your general solution to the whole problem is going to be the homogeneous solution plus this particular. Yeah? Keep in mind, the homogeneous, you're going to have those constants multiplied times everything, but this particular guy, it's just this guy. You're not going to multiply it by a constant. So your general solution is C1 e to the t times 1 negative 1 plus C2 e to the 2t times 1 negative 2. And then plus, and here's where don't add in a C3, right? It's just straight up this guy. T squared e to the t plus 2t e to the t plus 2e to the t and a negative t squared e to the t minus 4t e to the t minus 4e to the t. There's your general solution. All right. Let's do another example. All right, so example 2 gives me matrix A is 1, 2, 4, 3, and B is 12e to the 3t and 18e to the 2t. All right, so we start off by finding the homogeneous solution. You're going to start off by doing lambda I minus A, which will give you lambda minus 1, 0 minus 2, 0 minus 4, lambda minus 3. So that means your characteristic polynomial will end up being lambda squared minus 3 minus 1, so minus 4 lambda. It would be a plus 3 minus 8, so a minus 5. And that means that factors as lambda minus 5 and lambda plus 1. Plugging in when the first eigenvalue is 5, I would have 4, negative 2, negative 4, negative 2, positive 2. Sorry about that. 5 minus 3 is positive 2. All right, and then notice if you just add row 1 to row 2, bye-bye. That's nice. Okay, so first row says 4x1 minus 2x2 is 0, which means x2 is equal to 2 times x1. And so your first eigenvector would be, if I let x1 be a, then x2 would be 2 times a. And so your first solution is e to the lambda t times its eigenvector. Do the same thing for the second eigenvalue, which was negative 1. And negative 1 would give me negative 2, negative 2, negative 4. I can add negative 1 minus 3, it would be negative 4. And we're solving for when are these guys 0. And obviously, if I multiplied row 2 by negative 2 and then added it, this second row will go away, and you're left with a negative 2x1 minus 2x2 equals 0, which gives you that x1 is equal to a negative x2. And so my this would be k2. Eigenvector for lambda 2 would be, if I let x2 be a, then, yeah, I should have done it the other way, but oh well, that's all right. We got a times negative 1, 1, which means your second solution is e to the negative t times negative 1, 1. And obviously there's more than one answer, right? Because if I would have said, oh, x1 is a, then x2 would be negative a. So a 1 and a negative 1, perfectly fine answer as well. Okay, so that means my homogeneous solution is the linear combination of these two guys. So some constant times e to the 5t times 1, 2, plus some other constant times e to the negative t times negative 1, 1. So now my big capital U is made up of column vectors of the U1 and U2. So don't forget to distribute the e. So that's a 1 times e to the 5t, 2 times e to the 5t, first column. Second column will be negative 1 times e to the negative t, and then 1 times e to the negative t. Okay, so now I'll find the inverse of this guy. Would be 1 over the determinant, which would be a e to the 4t minus a negative 2e to the 4t, which means that this is a e to the 3e to the 4t. So you're going to be multiplying it by 1 over 3e to the 4t. All right, and then if u is this guy, we're going to flip-flop this diagonal. So now this is e to the negative t, and this is e to the 5t. These two guys stay in the same spot, but just change their sign. So this is now a positive e to the negative t, and this is a negative 2e to the 5t. And when you distribute that in, I'm going to go ahead and keep the 1/3 out front, just to be nice, but I can definitely distribute the 1 over 4t. 1 over e to the 4t. So multiplying that times e to the negative t will give me e to the negative 5t. Same thing here, e to the negative 5t. Negative 2 times e to the 5t divided by e to the 4t would be a negative 2e to the 1t, and then an e to the t. So there's your u inverse. Remember, C prime is u inverse times b. So I'm going to take this guy. I've still got the 1/3 out front. I'm just going to leave it there because it makes the numbers nicer when I go to multiply. And then I can distribute it at the end. Okay, so there's u inverse, and we're going to multiply it times b. And this b was 12e to the 3t and 18e to the 2t. So I'm going to leave the 1/3 out front, and I'm going to multiply these two matrices. 2 by 2 times a 2 by 1. My answer will be a 2 by 1. Element by element. Row 1 times column. E to the negative 5t times 12 e to the 3t will give me a 12 e to the negative 2t, and then plus e to the negative 5t times 18 e to the 2t. Then do row 2 times this column. Negative 2 times 12 would be a negative 24. E to the t times e to the 3t is an e to the 4t. And then plus e to the t times 18 e to the 3t. All right, so then all of these are divisible by 3. So let's go ahead and distribute the 1/3. That means this would be 4e to the negative 2t plus 6e to the negative 3t, and negative 8e to the 4t plus 6e to the positive 3t. So there's our c prime. That's what we've got to integrate now to find c. All right, so c will be the integral of this matrix. And it looks like it's going to be pretty easy to integrate, which is fantabulous. All right, so integrate it with respect to t, and that would give me got to undo the chain rule here, so it would be a negative 2 e to the negative 2t minus 2 e to the negative 3t. Undo the 4, so a negative 2 e to the 4t, and then undo the 3, so a plus 2 e to the 3t. All right, so that's C. Your particular will be matrix U times C, which matrix U was e to the 5t, 2e to the 5t, negative e to the negative t, and then e to the negative t. That was U. And we'll multiply it times this guy. Keep in mind, this is a 2-row by 1 column. It's not a 2 by 2. It's only 2 rows, 1 column. So watch out with that. I've noticed that sometimes when I'm grading your test, you'll see this and then you'll go, oh, those are 4 different elements. No, it's 2 elements. Here's one, and then here's another one. Love it when, I don't love it. I hate it when you misread your own writing. Frustrating on my end, because how do I figure out how much to take off? Okay, so we're gonna multiply these guys together. Row 1 times this column. This is 1 column. So element by element, you're gonna go e to the 5t times this whole guy, which will give you negative 2e to the 3t minus 2e to the 2t. That was just first element times this guy. Now we're going to go this guy times this one, still in the same first row. So that would make it a positive 2e to the 3t, and then a minus 2e to the 2t. So there's row 1. Row 2 you'll get from multiplying this guy times these guys, element by element. So this guy gets multiplied times this whole element. So that would be a negative 4e to the 3t, 2t times 2, that would be a minus 4e to the 2t. And then this guy times this second row, so a minus 2e to the 3t plus 2e to the 2t. Let's see if we can combine any like terms. Oh yeah, for sure. Look at that. Bye-bye, bye-bye. And then negative 2 and a negative 2 will leave you with a negative 4e to the 2t in the first row. Down here, we've got a negative 4 and a negative 2, so a negative 6e to the 3t and a minus 2e to the 2t. That's your particular. And so your general solution is going to be the homogeneous solution, which does have those constants in front of each of the factors, right? So or of each of the solutions. So 5t 1, 2 plus c2 e to the negative t times negative 1, 1, and then plus, and don't put a c3 times this guy. It's just straight up the negative 4 e to the 2t and a negative 6 e to the 3t minus 2 e to the 2t. I guess it's worth writing it, right? There's no C3 here. There's no constant times that last guy. It's just straight up having it there. All right. Now you are ready for the doozy. The doozy of a doozy of a doozy. For real. Example 3. All right. This is a 3 by 3. So a heck of a lot more work. 2, 1, 2, negative 2, negative 4, positive 2, 1, 1, negative 3, and B is T0, 1. Okay, so again, start off by finding the homogeneous solution. You'll do lambda I minus A and get lambda minus 2, positive 2, negative 1, negative 1, lambda plus 4, negative 1, negative 2, negative 2, lambda plus 3. All right. I have no zeros right now, so I would prefer to zero out something so that way I have less to multiply when I go to do this. And what I noticed is these two guys. Yeah. So I'm going to take negative row 2 and add it to row 1. So a positive 1 plus lambda minus 2 would leave me with a lambda minus 1. Negative lambda minus 4 plus 2 leave me with a negative lambda minus 2. A negative 1, so a positive 1 minus 1 will give me a 0. And that's enough. I'll leave everything else alone. Your goal is just to try to make your life a little bit easier. So now your characteristic polynomial will be the determinant of this guy, which will be lambda minus 1 times the determinant of this guy, which would be a lambda squared plus 7 lambda plus 12 minus 2, so a plus 10. I know I'm skipping steps. Hopefully you're okay with that. And then, again, I'm using this row. It would be a negative of this guy. So it's a negative of, I can factor that out. Yeah? A negative of, you're doing the negative because it's in this row 1, column 2 guy, right? But then I factored out the negative there just to make my life easier. And what you would be left with is taking the determinant of negative 1 times lambda plus 3, so a negative lambda minus 3, and then minus a positive 2. Yeah. And so you end up with a lambda minus 1 times that factors lambda plus 5 and lambda plus 2, and then this would be a plus lambda plus 2 times okay, I'm going to factor out that negative. Yeah. This is negative lambda minus 5. I'm going to factor that out. If I can actually make my tape work. Okay. So this was a plus, right? Whoop, whoop, plus. But here is a negative lambda minus 5. So I'm going to factor out the negative so that I would be left with a lambda plus 5. Nice. Okay. Right now, I would look for common factors, and I have a lambda plus 5 in common with this first term and the second term. I also have a lambda plus 2, so I'm going to factor them out. Factoring out lambda plus 5 and lambda plus 2, I would be left with a lambda minus 1, and then a minus, I factored both of them out, so you're just with a minus 1. Yeah, which means I've got lambda plus 5 times lambda plus 2 times a lambda minus 2. Okay, so now I've got my first eigenvalue of, why I chose the middle one, I don't know. Let's go with 5, negative 5. All right, so first eigenvalue is negative 5. And when you have a negative 5, you will end up, I'm going to just do some math magic here because this problem is going to take a while. So you should end up with, am I going to do that? Oh, no. You guys could always fast forward, right? I'll do it. Makes the video long, but what would that be? At negative 7 to negative 1, negative 1, negative 1, negative 1, negative 2, negative 2, negative 2. And we're solving for when that's 0, 0, 0. And so, how about this? I'll skip through these steps. I ended up with a whole bunch of row operations. Not that much, but what? I did 2 operations. And I ended up with a matrix of negative 42, 21, 0, 0. I ended up with 0, 9, 6, 0, and then 0, 0, 0, 0. That's how I ended up with, right? Your signs may be a little bit different. Your numbers, depending on what you did, you might end up with something a little bit different. But you should still get pretty close to the same answer as me. This first row says negative 42x1 plus 21x2 is equal to 0, which means x2 is equal to 2x1. Second row says 9x2 plus 6x3 is equal to 0, which means x3 is equal to a negative 3 halves x2. So what I'm going to do is let x1 equal a. Well, then x2 would equal 2 times a, and x3 would equal, if this is a 2a, then x3 would be a negative 3a. So your eigenvector here is a times 1, 2, negative 3. And so your first solution would be e to the negative 5t times 1, 2, negative 3. All right, we're going to do the same thing with the other two, and I think I'll do some math magic again if that's okay with you guys. Work it out yourself. But second eigenvalue was negative 2. And when you do that, you'll have a negative 4 to negative 1, 0, negative 1, 2, negative 1, 0, negative 2, negative 2, 1, 0. And then a couple, how many did I do? I did 2 row operations, and I ended up with negative 12, 0, 0. I did it. I had a 0, a negative 6, a 3, and a 0, and then a 0, 0, 0, 0, which told me that negative 12 x1 is 0. So x1 must be 0. And then row 2 told me negative 6x2 plus 3x3 is 0, which means x3 is equal to 2x2. So x1 is 0. I let x2 equal a, which means x3 is 2 times a. And so your second eigenvector is going to be a times x1 was 0, 1, and 2, like that. So that means your second solution is e to the negative 2t times 0, 1, 2. All right. Third eigenvalue was what? Okay, 2, positive 2. All right, so when I plug that in, I've got 0, 2, negative 1, 0, negative 1, 6, negative 1, 0, and negative 2, a negative 2, a 5, and a 0. And I did some row operations, 2, well, maybe even 3 sets of them, something like that. But 1, 0, negative 2, 0, 2, negative 1, 0, 0, 0, 0, 0. All right, so that's what I got when I did my row operations. Again, you might get something slightly different. It should be pretty close to something like that. All right, so row 1 tells me x1 minus 2x3 is equal to 0. So x1 is equal to 2x3. Second row says 2x2 minus x3 equals 0, and so 2x2 is equal to x3. So I let x2 equal a, which means x3 is equal to 2a, which means x1 would equal 2 times 2a, so 4a. So your third eigenvector would be a times x1 is 4, x2 is 1, and x3 is 2. And so your third solution will be e to the positive 2t times 4, 1, 2. All right. So what that means now is my homogeneous solution is the linear combination of these three guys. So C1 times e to the negative 5t times 1 to negative 3 plus C2 times e to the negative 2t 0, 1, 2, and then plus C3 e to the 2t times 4, 1, 2. Yeah? All right. Now we got to find u. Because that was just the homogeneous part, which we're going to include in our general solution, right? Okay. So u is going to be made up of each of these guys are your columns. So e to the negative 5t, a 2e to the negative 5t, and a negative 3e to the negative 5t. And then a 0, e to the negative 2t, and then a 2e to the negative 2t. And then the last one is a 4e to the 2t, e to the 2t, and then a 2e to the 2t. There's your u. And you need to find u inverse. Yeah? To find u inverse, I think the easiest way to do it is to augment this guy with the identity matrix. Like that. Right? And then do row operations. And what you want to do is get it to where this left-hand side is 1, 0, 0, 0, 1, 0, 0, 0, 1, right? And then everything else on the other side. And my notes are different from, yeah, that's fantabulous because I have different columns, which is fine. It'll still end up with the same answer, but whatever. Okay. We're going to do math magic. Yeah. So u inverse should end up with, you're going to do row operations, and it's a lot of them. And this video is already probably too long. Remember, you'll do row operations, get this guy to end up being, actually before I say u inverse, I'll say you're going to do a bunch of row operations, a whole bunch of row operations to end up with a matrix that is 1, 0, 0, 0, 1, 0, 0, 0, 1. And then the order is probably going to be different working this out because I had, this is column 1, that one is column 2, and that one is column 3. So that means it'll probably be, it's row 1. Okay, not positive, but it should be. Okay, column 3. Okay, so it should be, I think, right. No, I Hooper scooper. Okay. Let me say this. I had this column as column 3. I had this one as column 1, and this one as column 2. Our final answers will end up being the same. Okay. I just don't want to mess up and say, this is your answer when, if you go to actually work it out and you get something different. So if you were to have this is column 1, this is column 2, and this is column 3, you go and do a bunch of row operations, you should end up with a -1/4 e to the 2t, a 1/2 e to the 2t, a 1/4 e to the 2t, a 1/4 e to the -2t, a -1/14 e to the -2t. Yeah, none of you are probably going to even work it out because it really was a lot of work to get it done. But just in case if you do, you want to check what I got compared to what I got, then just know that I had my columns different. I had C1, C2, and then C3. Okay, so that's what I got using C1, C2, C3. So that's why I'm thinking that since this is C3, I'm thinking this is probably your first column, and then this is probably the second column, and this is probably the third column, whatever. Yeah, but whatever. Okay. All right, so I go and I get this. So by doing that, then this is your U inverse. Yeah. And remember, C prime is U inverse times B. So I'm going to take U inverse. I really don't want to rewrite it again. Oh, but I will. Okay, so no, I'm not going to. So it'll be U inverse, right, which is this whole guy, and then times B, which was T01. Yeah, this whole thing is in there. All right, and when you multiply those, you will end up with a, remember, row 3 by 3. So 3 rows, 3 columns by 3 rows, 1 column. You'll end up with a 3 by 1. And you'll go element by element. T times the -1/4 e to the t plus 0 times 1/2 e to the t plus 1 times 1/4 e to the 2t. So you end up with what is that? -1/4 t e to the 2t plus a 0 times this guy plus 1/4 e to the 2t. And then multiplying row 2 times this column, you've got a positive 1/4 t times e to the -2t plus a 0 times this guy plus a 1 times that one. And then row 3 times this column, 0 times t plus this times 0 plus 1 times -1/7 e to the 5t. All right, so that's C prime. Okay, we're almost there. We got this. So now C, now you know why this is the take-home part, right? I'm going to sit there for 2 hours while you do this problem. Okay, so C will be, I'm not saying it'll take you 2 hours, I'm just kidding. Okay, so we're going to integrate this guy. So -1/4 t e to the 2t plus 1/4 e to the 2t. 1/4 t times e to the -2t plus 1/28 e to the -2t, and then -1/7 e to the 5t dt. All right, integrating that, you do have to use integration by parts on this one and that one, but not on these two. So you'll end up with math magic, right? And then you get what did I get? I got a -1/8 t e to the 2t plus 1/16 e to the 2t. That was just the antiderivative of this first term here, and then plus the antiderivative of this guy. You got to undo that too, so it's a plus 1/8 e to the 2t. Second row, you have to do integration by parts on this one. Again, both of these are integration by parts, but you can do tabular on them, so it's not too bad. And you end up with a -1/8 t times e to the -2t, and then a -1/16 e to the -2t. That was just for the first term. And then antiderivative of this guy, you got to undo that -2. So a -1/56 e to the negative 2t. And then antiderivative of this guy, I'm doing that 5, will be a negative 1 over 35 e to the 5t. Okay, that's C. Your particular is matrix U times C, which will end up giving you, you're doing U, let's see, can I get it on the same page? You're taking this matrix here times this one here. Keep in mind, this is a 3 by 1. This is a 3 by 3. So you'll take row 1 element, so you'll multiply the e to the negative 5t times this whole row plus 0 times the second row plus 4e to the 2t times the last one. That's for the first row. So you'll end up with a right? Oh, except that remember I had this as my first column. See, I hate it when I venture off on my own because then like my final answers will be the same. It's just the work shown in the middle is just a little bit different, but that's okay. I don't want to work it all out again because it's a pain in the butt. All right, so you end up with that, and you end up with negative 1 over 8t plus a 3 over 16 minus 1 over 8t minus 9 over 112 and a minus 2 over 35. It's a whole bunch of math. Plus 6 over 16 minus 1 over 4t minus 18 over 112 and a plus 3 over 35. You should end up with, even if these terms are all a little bit mixed up and different, your final answer will end up being negative 1/2 t minus 7 over 20. Second row is a negative 1 over 4t plus 1 over 20. And the third row, negative 1/2 t plus 3 over 10. All right, that's UP. So now, final answer, and then we're done. Your general homogeneous solution is, not general homogeneous, your general solution, because it's the homogeneous with the particular, is the homogeneous. So C1 e to the, I did a different order in this one too. There we go. C1 times e to the negative 5t, 1, 2, negative 3, plus C2 e to the negative 2t, 0, 1, 2, plus C3 e to the 2t, 4, 1, 2, and then plus this guy, you know, but no constant times it, just straight up negative 1t minus 7 over 20, negative 1/4 t plus 1 over 20, and then negative 1/2 t plus 3 over 10. There you go. Work in the middle may have been a little bit different, but you should end up with something like that. Crazy, right? I know. All right. I hope you are having a fantabulous day. Bye.